The next get is the topic of WANs and MANs. A WAN is a wide area network. Generally, a WAN is one large network that covers a large geographical area. One of the best known WANs would be the internet. While WANs cover large geographical areas, they don't have to be one single network covering the large geographical area. A WAN can be made up of a lot of different smaller networks in different parts of a geographic area that are all linked together to form a large wide area network. In the event that you have a lot of smaller networks all linked together to a large wide area network, and that configuration is owned by a single company or single organization, then that type of network is often referred to as an enterprise network. Because of the size and scale of WANs, generally use routers and occasionally switches to connect up all the disparate networks that make up a large WAN. Another type of network is called a MAN. A MAN stands for Metropolitan Area Network, and it uses the same technology as a WAN. The difference is a MAN covers a much smaller area. In general, a MAN is only going to cover an area of only about 50 kilometers across, give or take a little. One thing to keep in mind about the term MAN is that it is falling out of use. Instead, more and more we're using the term WAN to apply to both WANs and MANs. About WANs and MANs, let's talk about networks on a little bit smaller scale. Let's go ahead and talk about LANs, WLANs, and PANs. A LAN stands for a local area network and is generally a network that is limited to a very small size or very small geographical area. It is very common for LAN to be as small as a single room, or they can even be as big as an entire building. Once in a while, you may even run across a LAN that spans several buildings that are close together. If the buildings are far apart, for example, in different parts of town or something like that, at that point, we no longer have a LAN, but we have a MAN like we talked about previously. The TIA EIA 568C standard defines the characteristics that make up a local area or a LAN network. LANs will usually use twisted pair cabling to connect the nodes or computers to a central device. If you're setting up a new LAN in a building that's just being constructed, or possibly you're putting up a LAN in a building that's never had a LAN before, you want to be sure to go ahead and use Cat6 or Cat6A cabling for the LAN. The reason you want to use the Cat6A or Cat6A cabling instead of some of the older versions of the twisted pair cabling is because the Cat6 and Cat6A have been optimized to accommodate future technologies that aren't even out yet in some cases. And so by using Cat6 and Cat6A, in a way, you're future-proofing the LAN you're building in the sense that the cabling infrastructure will be able to support newer, more advanced technologies as they come out. One thing to keep in mind about LANs is that the TIA EIA 568C standard only recognizes the hierarchical star topology as the only valid topology that you can use in a local area network. The central device that you connect different nodes or computers into in a LAN is generally going to be a switch, or in some older situations, hubs. While I said that twisted pair cabling is generally what's used to connect nodes or computers to central devices, oftentimes you'll have the central devices or the switches be connected together with fiber. As a result, we have the situation where your computer's linked to the switch using twisted pair, but if you have multiple switches in your network or in your LAN, you might have those switches connected together with fiber optic cabling. Another kind of LAN technology is WLANs. WLAN stands for wireless LANs. As the name suggests, the way you link up LANs in a WLAN is using wireless technologies. The wireless technologies used in a WLAN are commonly referred to as Wi-Fi. The Wi-Fi technologies used in a wireless LAN are defined by the IEEE 802.11 standard group. The IEEE 802.11 AC is the most current Wi-Fi standard at this point in time. However, A more advanced wireless standard, the IEEE 802.11ax, is being developed. So at some point in the future, the 802.11ax standard will replace the 802.11ac standard as the most current and most advanced Wi-Fi standard. PANs stand for Personal Area Network, and they are another type of small network that uses wireless technologies. PANs don't use the same wireless technology that WLANs do. In fact, most commonly, you're going to find a PAN using the Bluetooth technologies for connecting up devices rather than the Wi-Fi technologies. One of the limits of PANs over wireless LANs is that a PAN has a limited range of less than 30 feet. However, this limited range does have an advantage because it doesn't take as much power to generate a signal if you're only going 30 feet rather than the much longer distances that wireless LANs are able to connect at. A place you may see PAN technology would be examples of the wireless keyboards and mice that are often connected up to computers. Those wireless keyboards and mice are actually using Bluetooth PAN technologies to connect to the computer. Aside from wireless mice and keyboards, also many phones and smartphones use PAN technologies as well, specifically PAN Bluetooth, to connect up accessories. Some accessories you use with your phone that have Bluetooth technology or PAN technology would be things like the earbuds that are used so you can do hands-free phone talking while you're driving. In more recent times, those watches that you see that connect up to your smartphones and what have you, those are also using the Bluetooth PAN technologies. While PANs normally use Bluetooth technology, PANs don't have to use Bluetooth technology. PANs can also, in some situations, use infrared signals as an alternative to Bluetooth for connecting up devices in the network. Now we've talked about a few generalized network technologies. Let's talk about a few specialized network technologies. The specialized network technologies I want to look at right now are SCADA, ICS, and MediaNet technologies. SCADA stands for Supervisory Control and Data Acquisition. ICS stands for Industrial Control System. Both of these technologies refer to networks and technologies that are used to control industrial applications to some degree and to some scale. In the case of SCADA, which is a subset of the larger ICS technologies, when we use the term SCADA, we're describing systems that span large geographical areas. Some examples of SCADA systems that span large geographical areas are pipelines, power distribution, water management, sewage management, and even things as common as streetlights. ICS, while is the more generic term, when people use the term ICS, generally what they have in mind is smaller scale systems. The smaller scale systems they have in mind when they use the ICS term would be things like industrial automation, control systems for power plants, control systems for factories, and even control systems for HVAC or heating and air conditioning systems. Another type of specialized network technology are MediaNets. MediaNets refers to networking technology that's been optimized for distributing large video applications and similar technologies. Some MediaNets you may have heard of are things like Hulu, Netflix, WebEx, and GoToMeeting, among others. One of the ways that a MediaNet can handle such large-scale video applications is by using something called smart bandwidth detection systems. The smart bandwidth detection systems allow MediaNets to adjust to higher or lower bandwidth devices. The result is that the MediaNet is able to provide smooth video transmission on any platform, whether it is a slower or a faster platform. You'll still get the same kind of smooth video that you're used to in these various technologies.